Alright, so let's start with the inverse sine function. So just like in a quadratic, when I try to explain how you're restricting the domain, my first started by constructing the parent parabola, and that's what I'm going to do now. To find the inverse of a sine function graphically, I'm going to try to, I'm going to draw the sine function. So just to review our sine graph, the sine graph goes from 0 to, so I'm going to draw a couple of cycles, one on the positive and one on the negative. So this one cycle / period goes from 0 to, one wave is from 0 to 2 pi. Perfect, good answer. You guys remember this? Sort of? Unit 2? You shouldn't forget. Midpoint is pi, pi by 2, 3/4 point is 3 pi by 2. Yes? Sort of coming back? Yes. Give me 1 second. Let me just finish this. Yeah. And then, how does the sine graph go? It starts at the sea level and then goes up. That's what we're doing. And then my range is 1 and -1, right? So starts at 0, goes to 1, comes down, goes to -1, comes back up. One cycle. And then goes on. Yes, do we all remember this? Sort of coming back? Okay, awesome. And then on the negative side, again, I'm going to go from 0 to negative. I know we haven't done cycles on the negative side if you're doing the basic, but I'm going to go ahead and do it for a reason. You'll see why. -2 pi, -pi, -pi by 2. So because remember what I said that the sine, we only talk about one cycle, but that's not the actual in real life application. It's multiple cycles. You never see just one wave. If you look at the wave of something, of a keyboard or something, because they're all waves, sound waves, right? You won't just see one cycle. It'll be just zig, 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 zig. It'll be multiple waves. So basically, how does it go from 0 to negative? Same thing. It starts at the sea level, because it goes to -1, goes to 0, goes up and ends here. That's how my negative, sorry, it may not be the correct height and all that, but yeah. So I have a question for you guys now. Is this a function? Yes, because if I draw a vertical line anywhere in the graph, it will touch it only once. Yes? Okay. Is the inverse a function? Good answer. Because if I draw a horizontal line, it's touching it at multiple spots. Correct? That means the inverse will not be a function. It's not one-to-one. So I am going to restrict the domain. So I'm going to restrict the domain. So okay, so I'm going to kind of analyze it. So if I take from 0 to pi, does it cross the horizontal line? Not really. It doesn't. Okay, but I'm going to look at something else. What if I go from -pi by 2 to +pi by 2? This section. And you generally want it to go through 0, 0. You generally want to go through. So I'm going to go from -pi by 2 to +pi by 2. Do you think this passes the horizontal line test? Yes, if I definitely know it crosses vertical line, but if I draw a horizontal line, it crosses it only once. So you do restrict your domain, and your domain restriction is going to be from -pi by 2 to +pi by 2. This is going to be 1, this is going to be -1. At -pi by 2, it's -1. If you look at the original graph, the one that I've highlighted, at -pi by 2, it's -1, then at 0, 0, and then at pi by 2, it's 1. So it kind of looks like but it's a hard stop. Remember how we put arrows? Not in this, and should we have a little bit of curve, I think. But it's a hard stop, yeah. So this is f of x equals sine x. This is also f of x equals sine x with domain restriction. And I'm not going to go to the third graph. Third graph kind of makes you do the inverse and stuff like that. But I'm not going to go. So as long as you understand these two, it's good enough for now. Jalen, whenever you're ready, you can come and take this. Sure. Yeah, we're okay? Alright. So you have, what you need to know is sine inverse will take values only between negative pi by 2 and positive pi by 2. And I'm going to write this down. I'm going to write something here which about what we've just spoken. So f of x, what's the domain for f of x? Original function. Okay, going back to your unit 2. What is the domain for a sine function? Everybody agrees? Remember I said it goes on forever, right? My cycle's gone forever. What is the range? What is on the y-axis? Parent. We're talking about parent function. Alright guys, everybody should know this. What is the highest value on good Dominic? Yeah. -1 to +1. Awesome. Because we are talking about inverse, we are going to do a domain restriction. So my new domain, instead of this, it's going to be negative pi by 2 to positive pi by 2. So it will no longer be this. It will no longer be this, it will be that. And then I'm going to move on to inverse. Everybody okay? Can I move on? Okay. If you're talking about inverse, my domain is going to be what's my domain going to be? The range. Everybody clear about that? And my range is going to be, who can tell me what the range is going to be? Yes. Excellent. Excellent. It's going to be the domain, but remember I crossed that out and I replaced that with negative pi by 2 to positive pi by 2. Okay, I have a question. So now so this is about the domain and the range, and now I'm actually going to talk about f of x, f inverse of x. Basically I'm going to talk about the function. I'm trying to see. Basically I'm going to talk about sine inverse of x. I don't care that's an inverse or something, but basically I'm going to talk about this. We are all aware of, we all learned this. And I'm going to replace this with y equals to sine x. When I learned this, what is the, so remember function is nothing but a, and I've said this before, it's nothing but a rule. It's nothing but a process that's happening to the input. If it's a quadratic, it takes the input and squares it, because that's what needs to be done to calculate the area. The input, the length and the width needs to be, you need to square it to find the area of something. So it's a rule that is needed to calculate something, right? So when you have a trig function, what is the input for a sine function? What is this x normally? What are you trying to see? Sine of what? What is this normally? Is it a number? What is it? What does it represent? So I normally ask you sine of what? Equals to what? Is this a valid statement? So the input for a sine function is, guys, what's this? An angle, right? Sine, cosine, tan, all the trig functions, the inputs are angles. I know math is abstract, but we should be able to think about functions in terms of inputs and output. When you're talking about a trig function, the input for a trig function is an angle. What is the output? What is this called? It's a number, it's a fraction, alright, but what is this fraction? Can you give me one more step? It's always a ratio, because sine is opposite by hypotenuse, cosine is adjacent by hypotenuse. So it's always a ratio. Even if it's a whole number, you put a 1 at the bottom. So the input for sine, the reason I'm giving so much stress on input and output is because we're going to switch it, so you should know that. The input for a sine function is an angle, the output is a ratio. Sine of 30 degrees is half because the opposite side is 1. Any triangle you take, if it has a 30 degree, the sine of the 30 degree, the opposite side will be 1, the hypotenuse will be 2. Or the ratio will be 1:2. Not necessarily 1 and 2, but ratio will be 1:2. That's what it basically means. So what does it mean in this case? So sine inverse, what do you think this x is going to be? Because remember we are switching the domain and range. So what do you think this is? The input is going to be. The output is a ratio, so the input here will be ratio. So the input for sine inverse is always a ratio, and the output is the angle. Alright, you need to know this because we will be basically asking you a bunch of questions. What is sine inverse of half? What is sine inverse of square root of 3/2? You should be giving me the answer in terms of angle. Okay, so that's why we use, not only have we talked about graph, we are also going to use a unit circle. So pretty much you use a lot of the units that you've seen before. Okay, can I take this off? Anyone still? Alright. Just one more thing before I actually talk about the table, that sine inverse is also called as arc sine. And so sine inverse, and I'm not going to fill these in because you don't need to know this, because this is the same thing as all of this except written in a little more confusing way, so we'll leave it. All you need to know is sometimes instead of sine inverse you will see the word arc sine, and you'll see that here too. Okay, this circle is important. It is your unit circle, and you see quadrant 2 and quadrant 3 saying D and E does not exist, and why? The reason is this is the circle for y equals sine inverse of x. And what did we say the domain restriction was for sine inverse? How did we restrict the domain for sine inverse? Oh, sorry. The domain for sine x to come to sine inverse. How did we did the domain restriction between negative pi by 2 and positive pi by 2. Correct? You guys remember that? My domain restriction was, that's what we talked here. A good domain restriction for sine inverse was so that the inverse is also a function. Where is negative pi by 2 on my unit circle? Where is pi by 2 on my unit circle? So the only values that exist for sine inverse is between negative pi by 2 and positive pi by 2. Everybody clear so far? And now I have to mark my unit circle. I have to mark my unit circle with the different angles. So on my quadrant 1, so y sine, okay, let's fill this in. Y sine inverse of x does not exist in quadrant 2 and quadrant 3, right? Because of the restriction placed on my function in order to make the function 1-to-1. Alright, so now let's go ahead and mark these because we need to know the angles in between. So we know how the angle goes, pi by 6, same thing, pi by 4, pi by 3, and pi by 2, and of course 0, I forgot the 0. What is the sine values for each of these angles? Because that will actually be the input. This is going to be, remember what I said, this is going to be the output. So pi by 6 is, we all remember this, it starts at 0, goes to half, We all remember how the sine value goes? Goes from 0 to 1. So it slowly increases. Square root of 1 over 2, square root of 2 over 2. This one is square root of 3 over 2. And this is 1. Square root of 4 over 2, which is 1. Everybody good? Now let's fill in quadrant 4. It's from 0 to, do you mind getting the door for me? The door. Thank you. Now we go from 0 to negative pi by 2. Okay, so it's in the reverse direction. It's negative. So same thing as this. Negative pi by 6. Negative pi by 4. Negative pi by 3 and negative pi by 2. Can we write the ratios for sine? So negative pi by 6 will be the same as reference angle. Same as pi by 6, right? That's how it works, reference angle. Except it will be negative because sine is negative in quadrant 4. Everybody okay? Negative half, negative square root of 2 over 2, negative square root of 3 over 2, and negative 1. These are the different values. And these values will allow me to fill in this table. Okay, I'm going to give you guys 30 seconds, finish this up, and then we're going to start this table. This table will not take us any time because we have this. We just have to understand how to read it and write it down. So remember I said sine inverse can also be written as arc sine. So if you see arc sine, don't be confused. Just replace that with sine inverse, and that's what I like to do because I'm used to sine inverse. So the minute you see sine arc sine, I'm going to rewrite it as sine inverse of negative 1. But you don't have to. You don't have to. So the way you want to ask yourself to give an answer to this is sine inverse. So you want to ask yourself, at what angle on the unit circle is the value of sine negative 1? It is negative pi by 2. Because remember, the answer should be the angle. Right? The input is a ratio, the output is an angle. Again, at what angle is the value of sine negative square root of 3 over 2? Okay, so my answer could also be, where else is it negative square root of 3 over? It can also be in quadrant 3. Right? Sine is positive here. Sine is positive in these two. It's negative here. I can also pick an angle from quadrant 3. Except I can't. Because I have a domain restriction. That is why you only pick, when you see negative, you only pick from quadrant 4. When you see positive, you only pick from quadrant 1. So there's no duplicity. There are no two quadrants. Even though there are two quadrants where sine is negative, it's actually only one quadrant. So at what angle is value of sine negative square root of 3 over 2? Negative pi by 3. Correct? Okay. Why don't we all fill in the rest of these angles? You should be able to fill this in based on what you've just filled in. It's a reverse of what you're used to. And I'll also fill in the quadrants. I filled in the first two quadrants, you guys can fill in something similar. Okay, go ahead and check in the values. I've just filled it in. I'm filling up the quadrant. All the negatives are in quadrant 4. Don't forget the quadrantal angles. The one that's on the axis is quadrantal. And all the positives are in quadrant 1. Bless you. So go ahead and check. It's pretty straightforward. I'm just picking up stuff from just the way it's written is opposite. That's all.